This is Saxon Math. We're doing lesson 75 today. We're going to be learning how to do area of complex figures. That means it's bigger than just a square or a rectangle. And area of a trapezoid. Remember, a trapezoid has one pair of parallel sides, like the top and bottom, but not two pairs. So if the top and bottom are parallel, the sides are not. So let's use what we already know about area to help us first with complex figures. When you have a complex figure like this, the strategy for finding the area is very simple. You're going to use the two areas you already know. One, you already know how to find the area of a rectangle. Area of a rectangle equals length times width. I'm going to draw a little rectangle over here so remember that that's area of a rectangle. Start first, always first, by looking for your rectangles or squares. In this problem, they've already told me that these two sides are parallel and these two sides are parallel. So I can imagine a line here that would break this up into a rectangle and a triangle. Well, here's my rectangle. My rectangle is 10 units long this way, and it's 7 units long that way. Since area is length times width, I can use this as my length and my width. That would be 10 for the length times 7 for the width. So my area of my rectangle would be 70 units squared. After you've done your rectangle, always do the rectangle first. Always. Otherwise you'll get a weird figure. Then I can use what I know about area of a triangle. Area of a triangle, as you know, is length times width divided by 2. It's for triangles. Now that I've found my rectangle, now let's look for a triangle. I have one right here. Then I don't have any of those sides. Let's see if we can figure out the sides. I already found this rectangle, and it was 10 by 7. That means that this side is also 10, and this side is also 7. Well, this side is 7 from here to here, and the whole thing is 16. How big must this piece be? Well, it's going to be 16. Take away those 7, and what I'm left with is 9. 9 plus 7 is 16, or 16 minus 7 is 9. So this length of this side would be 9. Remember on a triangle, and I put it as length times width here because that's sometimes how I think of it, but I believe a more accurate term would be base times height. Remember when we're looking for, if this is our length, what we sometimes call width, but what we're definitely going to call height right now, is always straight up and down. I would never want sort of a sideways angle because that wouldn't give me the height. I want to go straight up to the top. I know that this side is 10, which means that this side must also be 10. If this whole thing is 10 and this piece is 4, how big is the other piece? Well, if I have 10 and I take away 4, that means this piece is 6. Now I can solve my problem. I have a base and a height. Area of a triangle is base times height divided by 2. So my area is going to be 9 times 6 divided by 2. 9 times 6 is 54 divided by 2. Or 54 divided by 2 is 27 units squared. So if this area is 70 and this area is 27, finding my area of my whole figure then becomes much easier. I can simply add this area plus this area to get my total. So the area of this complex figure would be 70 units squared. That's the area here. Plus the area here. 27 units squared. To make a total of 97 units squared. Go ahead and finish writing this on your paper while the bell rings. Let's try one more. Here's another complex figure. going to use the same system. First, we're going to look for rectangles and squares. Then we're going to look for triangles. When I look here, I could split this up the way I did that one. I could split right down here, and it would give me a rectangle. It would give me a 10 by 6 rectangle. And then I could split right across here, and it would give me another little rectangle here that I could find, and then I got a triangle. I want to show you a different way to do it, though. Some people, when they look at this, instead of seeing the rectangles inside, the rectangle that they see is outside. Some people look at this, and they see this rectangle with a piece missing. This is another way to solve this problem. We could find the area of this whole rectangle, and then subtract out the triangle that's missing. Let's use our formula. Area of a rectangle is length times width. I have a length, and I have a width. My length is 10, my width is 10. So the area of the whole thing is going to be 10 times 10, or the area is going to be 100 units squared. Now let's subtract out this piece to find the area here. If this length is 10, that means this length is 10. But I want to find this length so I can subtract out my triangle. If this whole thing is 10, and this much is 6, that means that the piece that's left must be 4, because 4 plus 6 more would make 10. I can use the same strategy here. This side is 10, this side also must be 10. If this is 10 and this part is 3, that means the piece that's left must be 7. Now I can use my area of a triangle formula to help me. Area of a triangle is base times height. When I look at this one, I want to look sideways. Here's my base. My base would be 7. Times my height would be 4. Divided by 2. 7 times 4 would be 28. Divided by 2 would be 14. So this whole area is 100, and this triangle is 14. Let's subtract. Take the whole area, subtract out the triangle, and that will leave me with the area of the rest of my figure. So we have our 100 units squared for our triangle, minus our 100 units squared for our whole rectangle, minus our 14 units squared for the triangle we're going to take away, leaves me with 86 units squared, which is the area of this complex figure.